We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello student, myself Professor Madhuri Parekh, Computer Engineering Department from AIT College. Today we learn the topic pipelining dependency. Pipelining dependency, this topic is related to a previous video, that is pipelining technique. Here the dependency in a pipeline processor, there are mainly 3 types of dependency possible in pipeline processor. These are structural dependency, control dependency and data dependency. These dependencies may introduce stall in the pipeline. What is meaning of stall? A stall is a cycle in the pipeline without a new input. So let's start from the first dependency, that is structural dependency. The dependency arises due to the resource conflict in the pipeline. A resource conflict is a situation when more than one instruction tries to access the same resources in the same cycle. A resources can be register, memory or ALU. Now next we see the example. स्टूडेंट समझ में आया डिपेंडेंसी का मतलब है कॉन्फ्लिक्ट इफ एनी काइंड ऑफ कॉन्फ्लिक्ट either there is resource conflict, data conflict or structural conflict. So now we see the diagram. In this diagram, in cycle 4, instruction I1 and I4 are trying to access same resources, that is memory, which introduce a resource conflict. To avoid this problem, we have to keep the instruction on wait until the required resources become available. This wait will introduce stall in the pipeline as shown in below. Here in the diagram, they can give the yellow remark that is known as a wait state. You must wait up to the memory is released from the other instruction, that is known as a structural dependency. To solve out this kind of conflict or this kind of problem, to minimize structure dependency stall in the pipeline, we use a hardware mechanism called renaming. Here renaming, that means what? According to the renaming, we divide the memory into 2 independent modules used to store the instruction and data separately called code memory and data memory respectively. The code memory will contain all the instruction and data memory will contain all the operand that are required for the instruction. Okay, यहाँ पर डायग्राम में आपको दिखाई दे रहा है कि CM that means code memory and DM that means data memory. Now another is control dependency, that is also known as a branch hazard. This type of dependency occur during the transfer of control instruction such as branch, call, jump, etc. On many instruction architecture, the processor will not know the target address of this instruction when it needs to insert the new instruction into the pipeline. Due to this, unwanted instructions are fed to the pipeline. Consider the following sequence of instruction in the program. On 100th location, I1, on 101, that is a instruction 2, that is jump 250. So now the cursor is moved on 250 memory location, and that is a branch of I1. So expected output is I1, I2 and BI1. So you can see the output at here, expected output, that is I1, I2, I3 and BI1. So the output sequence is not equal to the expected output. That means the pipeline is not implemented correctly. To correct the above problem, we need to stop the instruction fetch until we get the target address of branch instruction. This can be implemented by introducing delay slot until we get the target address. जब तक हमको टारगेट एड्रेस नहीं मिलता है तब तक उसको डिले स्लॉट रखना होता है. So the output sequence I1, I2 and delay and then BI1. As the delay slot perform no operation, this output sequence is equal to the expected output sequence, but this slot introduced stall in the pipeline. Solution for control dependency. Branch prediction is the method through which stall due to control dependency can be eliminated. In this, at the first stage, prediction is done about which branch will be taken. For branch prediction, branch penalty is 0. Here, branch penalty, the number of stalls introduced during the branch operations in the pipeline processor is known as a branch penalty. As we see that the target address is available after ID, that means instruction decode stage, so the number of stalls introduced in the pipeline is 1. Suppose the branch target address would have been present after the ALU stage, there would have been 2 stalls. Generally, if the target address is present after kth stage, then there will be k-1 stall in a pipeline. So the total number of stalls introduced in a pipeline due to branch instruction equal to branch frequency into branch penalty. Now the third one dependency is known as a data hazard. Let's consider an add instruction as such that s colon add r1, r2, r3. Address is read by s equal to input, that is r2, r3, and address written by s output in r1. Now we say that instruction S2 depends in instruction S1 when input of S1 union output of S2 union output of S1 union input of S2 union output of S1 union output of S2 will not be 5. This condition called Bernstein condition. 3 cases exist. Flow dependency, that means S2 and S1 write after something read by S2. Anti-dependency, that means S2 and S1 read something before S2 overwrites it. Output dependency, that means S2 and both write the same memory location. For example, let there be a 2 instruction I1 and I2 such that add R1, R2, R3 and instruction 2 subtraction R4, R1, R2. When the above instructions are executed in pipeline processor, then data dependency condition will occur, which means that I2 tries to read the data before I1 writes it. Therefore, I2 incorrectly get the old value from I1. To minimize data dependency stored in the pipeline, operand forwarding is used. Operand forwarding, it means in operand forwarding, we use the interface register present between the stage to hold intermediate output. So the dependent instruction can access new value from interface register directly. That means कि जिस ऑपरेंड की रिक्वायरमेंट है उस ऑपरेंड को रजिस्टर में स्टोर कर दो, तो जो इंस्ट्रक्शन उस ऑपरेंड का यूज करना चाहता है तो डायरेक्टली इंटरफेस रजिस्टर में से वो वैल्यू यूज कर सकता है. दैट type of mechanism is known as a operand forwarding. Consider the example. Instruction 1 add r1, r2, r3 and instruction 2 subtraction r4, r1, r2. So here data hazards occur when the instruction that exhibit data dependence modify data in different stage of pipeline. Hazard cause delay in the pipeline. There are mainly 3 kind of data hazards. Row, that is known as a read after write. Flow through data dependency. Second one is a write after read. Anti-data dependency. And third one is a write after write output data dependency. Let's there be a two instruction I and j such that j follow I. Here it is row. It means read after write occur when instruction j tries to read data before instruction I writes. It example R1 plus R3 is stored into R2 and R2 plus R3 is stored in a R4. That means read after write. Then write after read hazard occur when instruction J tries to write data before instruction I read. Here is example R1 plus R3 stored in a R2 and R4 plus R5 stored in a R3. So here the write after read hazard occur. Right after write hazard occur when the instruction J tries to write output before instruction I write. R1 plus R3 is stored in a R2. At same time R4 plus R5 stored in a R2. So WAR that means write after read and WAW write after write hazard occur during the out of order execution of the instruction. This is known as a pipelining dependency that are the conflict part are there. It is very small topic. Sometimes it may be asked in your GTU exam. If you have any query and doubt, so give me a WhatsApp message or give me a query in my email ID. Thank you.